All right, everybody. Welcome. So as I'm passing some things out, we're going to go through some first day slides and some different things. So why don't we go ahead and start by introducing everybody? You already printed it out? Okay. Everybody's got it? Anybody not have a copy of the syllabus? Do you want a copy of the syllabus? Yep. You need a copy. Anybody else need one? Notice I got a bottle of fairly clear liquid up here. And when I shake it, notice that it changes colors. And so, let's keep watching it for just a minute. Tell me if it does anything else. Is it getting lighter? Is it getting darker? No? Think it's getting darker? You still think it's getting darker? Why do you think it changed colors when I shook it? What about the shaking process made that change colors? Okay, so I'm putting energy in it for sure, right? So something, definitely putting some energy in it. Is that the only thing that it could be? How might we test your hypothesis that it's the energy that I'm putting into it? Okay. What else could it be? What else is happening when I'm shaking? No, not magic. We don't live in the world of magic here. What? Ah, okay. So maybe we're dissolving gases into the solution. What does air contain? Nitrogen. Is nitrogen particularly reactive? Somewhat. What else? Oxygen. Is oxygen reactive? Very reactive, right? So let's suppose that we're under the assumption that it's due to oxygen. How might we test that hypothesis? Do what? Yeah, right. So I could go get a balloon full of oxygen gas, I could bubble it through, and if it changed colors, then that would support that hypothesis, right? And so a lot of the things that we're going to be learning about this semester, we're going to be talking about the scientific method throughout. We're going to be actually asking thought questions about how we could prove or disprove some of the things that we're going to be talking about. It's a very important technique for you all to have, especially for those of you who want to go on to medical school. So being able to look at an observation, okay, make a hypothesis, and then test that hypothesis. That's exactly what you'll do when you go to medical school. Doctors don't call it that, but they make observations of patients, right? They form a hypothesis, which is, I think you have, and then they test that hypothesis by saying, if you have this, I'm going to prescribe this, and it should clear it up, right? It is the scientific method. How about now? What do we got now? It's clear. Huh. Let's see what happens if I shake it up again. It goes back blue, right? So we could test that hypothesis. I want to talk to you a little bit about a few first day slides, and then we'll get into the organic chemistry stuff that we need to talk about today. So I want to welcome everybody. I'm Dr. Doug Masterson. I'm going to be your instructor in this class this semester. And I want to have a quick opportunity for everybody to introduce themselves and tell me what their major is. We'll start with you.
I'm a geologist.
Now, what's your first name again?
Obry.
Obry. Okay.
Grace Detmar, I'm a microbiology major.
Okay.
Lauren microbiology major.
Okay.
Olivia Shelton, and I'm a chemistry major.
Good.
Matthew Dia, and I'm a biochemistry major.
Okay.
Chef Dalu, and I'm a biochemistry major.
Uh-huh.
Elizabeth Lawhead, I'm a microbiologist.
Okay.
Gabrielle Reese, I'm a microbiologist.
Okay.
Ian Miller, I'm a pharmacist.
What was your first name again?
Ian.
Ian? Okay.
Jordan Weintraub, pulmonary engineer.
Okay.
John Michael Stewart, biochemist.
Light microbiology.
Okay.
Sarah Reese, microbiology. Megan Stapleton, general biology.
Okay.
Amber Coates, microbiology. Caroline DeGraw, biochemistry. Sarah Bell, biochem.
Okay. There's a difference. Okay.
Dane Wedgeworth, polymer science.
Okay.
Tony Peterson, microbiology.
Sarah Polly, biochem.
Matt Moran, polymer science.
All right. Well, welcome everybody. And just to let you know, except for a few of you, I will forget your name between now and Friday. Do not be offended by that. I will remember your faces. I'm very good at faces. I'm very bad at names. So if I point at you, it's not being rude. It's just deal with one of my deficiencies, okay? So we'll get through it. So one of the things that we're trying to promote here at USM, of course, is college success, being a successful student, being honor students. You all know all this stuff, but I need to go over it anyway, right? So what does it mean to be a successful college student? Successful college students have certain habits. They have a habit of regularly attending all of their classes. They have a habit of building professional relationships with their instructors, okay? Getting to know their instructors beyond just being in the class for 50 minutes 3 times a week. They plan ahead. They know when the next exam is. They know when the homework assignments are due. They follow their syllabus as a roadmap. They submit all their assignments on time. They don't procrastinate. That's a big one. They set goals for themselves beyond just attending class. They have career goals. They have goals that they want to attain after they graduate. They study quite a bit, right? Remember that a student study load for every hour that you're in this class, and an hour in an academic world is 50 minutes, okay? You need to spend about 2 hours of outside study class. That's going to vary from topic to topic. These first early topics, which are going to be largely a repeat of a lot of Gen Chem stuff, you won't be spending that much time. But on average, it comes out to about a 1 to 2 ratio, okay? Should you need academic help, you need to know that academic help is available across campus. You can find it all over the place, okay? If you need help with your writing, you can go to the Writing Center. If you need help with your math, you can go to the Math Tutoring Center. Chemistry, we have a chemistry tutorial center. You all probably know where that's at. It's right across from my wife's office in Walker Science Building. I will spend 1 hour a week in the tutorial center on Tuesdays from 10 to 11. We'll talk more about that in a minute. But successful students also seek help when they need it, okay? And so don't be ashamed if you need help in a particular topic. A lot of stuff is going to be coming at you quickly. Everybody needs a little help every now and then, so it's okay. Seek the help that you need. Don't be afraid to use the resources which we are providing you. There is also a student success series. I would highly recommend that you consider attending some of these, okay? These are just some examples that are out there. You can find the whole series at this particular website, okay? Student success series. You'll be able to find everything that's there. Some of them are pretty cool. Don't be a SOAR loser. That's kind of corny, but you know, if you have trouble figuring out how SOAR works, you all are far enough along. You probably know how SOAR works pretty well. Show me the money on ways to manage your student loan debt and other things. So if you have student loans and you need to think about those types of things, that would be a great one to go to. Eagles in Action, becoming civically engaged, especially if you're thinking about going to med school. You know, you got to do all that volunteer stuff. That's a great one to go to get some information on how you can be more engaged with the community. And Commit to be Fit, Study Fit. If you're struggling with some issues on your study habits, you might want to consider going to that one on October 5th. There are others. These are just some of the highlighted ones that I wanted to put on these first day slides. Also, successful students, we know, are quite heavily involved in student organizations. So think about that. Now, a lot of these, I put a whole series of them up here because we have, as you heard, a whole range of majors, right? But if you're a chemistry or a biochemistry major, there's the American Chemical Society Student Affiliates Chapter, which typically meets on Tuesdays at noon. free pizza. It's a great one to join. If you're in computer science, the computing one, forensic science, there's a Forensic Science Society. There's Tri Beta, which I don't think I have listed up there for those of you in biology. Women in Science and Engineering is a good one. So there's a whole list of potential student organizations that you can get involved in, and I highly recommend that you get involved in at least one student organization here on campus. Also, don't forget about career services. You all are sophomores for the most part, right? You're thinking, I've got 2 years to worry about that. It will be here before you know it, okay? It's not too early to start thinking about your future career and utilizing career services. Not only do they do things about jobs, they do things on campus, or jobs for Eagles if you're interested in that. Also getting involved in internships. They're helping people find those internships that help make them successful and land that job after they graduate. It's free. Don't be afraid to go and use their services. There's their number on the slide. And again, the slides will be posted, so don't worry too much about copying all this down. So career services is there. You all are in Organic Chemistry 1, as you all know, right? You may be thinking, why do I have to be in this class? How many of you have heard rumors about organic chemistry? And how many of those rumors were pleasant? The hands go down, right? That's right. Organic chemistry is not that difficult in terms of its content. We're only dealing with a very small piece of the periodic table, but we're dealing with a part of the periodic table that's very powerful. And why do you need to know something about organic chemistry? I heard that there's biology majors. I heard that there's polymer science majors. How many of you want to be physicians? Right? Or go into some kind of medical field, right? Why do I need to know about organic chemistry? It's because organic chemistry truly is the chemistry of life. You cannot understand biochemistry without a solid foundation in organic chemistry. We are organic based. Okay? DNA is an organic molecule. Proteins are organic molecules. Enzymes are organic molecules. They will follow the laws and that we talk about in this course. Okay? So having a good solid foundation here will help you with that. For those of you who want to go to medical school, the way that you think in organic chemistry is exactly how you have to think as a physician. We quite frequently have to think backwards. Not backwards thinking, but thinking backwards. And it's exactly how you're going to think as a physician. A patient walks in, they're sick. You have to work backwards to what you think the root cause of that is. I'm going to, at some point, give you a molecule and ask you to synthesize that for me. You've got the end point, and you have to work back to the starting point. It's exactly that technique, that way of thinking, that is going to be so important for you when you get to medical school, okay? Because you're going to have to do that all the time. So today I want to talk about a little bit of an introduction to the course. I want to talk a little bit about how we learn, your mindset, talk a little bit about the syllabus, and then why organic chemistry is important. Okay, we've already talked a little bit about that. So, class information. As I mentioned, I'm Dr. Doug Masterson. I'll be your instructor. I'm also the Associate Dean in the college. You'll see my office location. I technically have 2 offices. I have an office just down the hall. I'm rarely there anymore, but sometimes I am. So if you see me in there, feel free to walk in. Most of the time you'll find me downstairs in Tech 103B in the Dean's office. You are more than welcome to walk into my office if my door is open and talk to me, okay? I have an open door policy and I want you all to know that, okay? Do not be intimidated by walking through the front door of the Dean's office. It does not mean you're in trouble, okay? It is okay to come in and visit, okay? I have 2 phones. The 4880 is my direct line downstairs. That would be the one that would be the easiest for you to get in touch with me. Office hours, Tuesdays from 10 to 11 in Walker Science in the Tutorial Center. However, like I mentioned, I have an open door policy. I'm here to help you anytime that I can. However, if you come in and I'm in the middle of something really important, I may have to say, wait a second, okay? But I will get to you, I promise, okay? And don't be afraid to come in and just drop by if you're in the neighborhood. My email is douglas.masterson@usm.edu. It is the easiest way to get in touch with me. And I typically check my email up until about 11 o'clock at night, okay? After 11, if you send me something, I'm not going to respond till the next day, okay? And then if you need to Skype me, you can Skype. It's douglas.masterson, and we can have a Skype conversation if we need to. The textbook for this class is Organic Chemistry, the 12th edition. It looks something like this. I have a copy on reserve in the library if you do not have a copy. If you have the older edition of the textbook, I'm fine with that, okay? But know that the problems in the textbook have changed a little bit, and you may need to go to the library and look up some of the problems in that particular edition just to make sure that you're working the right ones that I've assigned for your practice, okay? A model kit is required in the class. Over in the bookstore, they sell, I believe it's called Model Kit number 1. I have one that's in a plastic case. They are identical kits, but if you want the one in the plastic case, because it does carry around a lot easier, doesn't get smashed like the cardboard box or the one that they sell over there, you can order it directly from Darling Models. And they used to be around $20, $25, something like that. So you can go there and find that if you want. But you will need a model kit for this class, and you will need to bring it in the not so distant future. Okay? Let's talk a little bit about this course. The emphasis of Organic Chemistry 1 is the language of organic chemistry and structure-energy relationships. The language. What you are going to go through this semester is like learning a foreign language. You are going to learn new nouns, adjectives, and verbs, okay, in terms of chemistry. We will learn how to name things. We will learn how to talk like an organic chemist, okay? We will learn how to think like one. We are going to cover, hopefully, chapters 1 through 10, barring any sort of hurricane catastrophe, okay? Hopefully, we won't have that. But the goal is to get to chapter 10. Okay? The graded work for this class is there will be 3 50-minute exams. There will be a comprehensive final. There will be online homework through Sapling. There will be a video project, and there will be inverted lectures. Does anybody know what an inverted lecture is, or a flipped lecture? It's not where you actually teach, but you will go and listen to, say, a pencast or a YouTube video or something like that that I've done. Then you'll come to class and you'll work together on a select set of problems that I've given you together. Okay? It is really where learning happens, okay? And so I do that approximately once every chapter. And so in the syllabus where it says INV, that's an inverted lecture, and you'll need to go to the Blackboard page and look and see what the pencast is. I suggest you look at those pencasts now to make sure your computer will run them. All you need is Windows or Mac, and you need Adobe Reader, one of the more updated versions of Adobe Reader. Okay, I have one of those fancy LiveScribe pens that allows me to write and talk, and it records it all together. And they're typically 5 to 10 minutes in length. That's what you'd have to do before you came to class the next day on an inverted lecture, of course, having read the textbook as well. Okay? Organic chemistry can be a difficult subject for many people. It's not the content, it's the volume. Okay? There's going to be a lot of stuff coming your way in a very short period of time, okay? So good study habits are essential. It is your responsibility to come prepared by reading the assigned material beforehand. When I step into this classroom, I assume you have read the material. I am not going to go over the material sentence by sentence from the book. You do not need me to deliver content to you like that, okay? I'm going to cover the stuff that I think you have the most difficulty with to try to clarify, okay? And so you need to come prepared having read the material beforehand, okay? You all have the study tips. I heard everybody talking about that. That's good. You will return that to me by 5 p.m. today, sign the front page. I just need the top page, and you're going to get 5 bonus points for that. That's 5% of an exam. Those study tips are very, very important, okay? They're a bit dated now. But I like them, and I think they still work. You need to practice daily or regularly, whatever your schedule allows. You need to write everything out. You need to always do your best work. It's kind of like sports. How many people in here played sports? Okay? How many of you only just showed up to the games? None of you. Why? Sarah, when you were in band, did you just show up the day of performance? No, you put in a lot of practice, right? And you put in practice like you want to play. When you're doing your homework, think of it as an exam. Am I grading it like an exam? No. But if you're just doing sloppy work on your homework, guess what you're going to do when you get on an exam? You're not going to do your best work, okay? Do not worry about the grade in this class, and I'll tell you why here in just a minute. Worry about your work. The grade will take care of itself, I promise, okay? This class does not have to be all about the grade. It's about learning, okay? And I know that sounds weird because you're all going, I need a good grade to get into med school, and I get that, okay? But I don't want you just to worry about getting a good grade. I want you to learn the material. I want you to advance. I want you to learn, okay? And if you do that, and let's say you get a B, and you come to me and ask me to write a letter of recommendation for you for med school, I can still write you one of the best letters that I've ever written. The best letter I ever wrote was for a student that got a B in my class. Got into med school, did just fine, is now a practicing physician. Okay? It's fine. You can make it, I promise. Okay? How do we learn? I like some of this stuff. This came from Worth and Perkins in a piece that they wrote a while back. You can find it, the whole thing, if you want to. But I like this little comic strip. I taught Stripe how to whistle. I didn't hear him whistling. I said I taught him. I didn't say he learned it. Right? I can't learn you. I can help you learn. I'm a learning facilitator. I really don't even like the term teaching anymore, okay? It's really a single person sport. You have to learn the material, okay? But I'm here to help you with that. And I'll do anything that I can to help you do that, okay? And there is a learning cycle. There is watching, kind of what you're doing right now, right? Then there's abstract, thinking about it. Then actually doing something. That's why we've got the inverted lectures. You're actually going to come into class and do something, right? And then there's this experience called feeling, how you feel about it, okay? Now, I'm a scientist. I'm not all touchy-feely about things, but it's part of it. It is really part of it, okay? And to have those experiences is how you're going to learn. If you only do one or two of them, you're going to struggle with your learning. You do all four of them, you will have a better time learning this material. And there are many levels of thinking and knowledge. There is knowledge, which is facts. When I went to college, facts was very, very important. I went to college pre-Google days, okay? So when I went to class, it was all about the instructor giving me information, giving me his or her wisdom, right? You don't need me for that anymore. You've got Google. You've got Wikipedia. You've got access to more stuff than you can possibly know about. So guess what? The exams aren't all about can you regurgitate a fact anymore. Can you use those facts? Can you access those facts? Okay? Then there's comprehension, there's application, there's analysis, synthesis, and evaluation. And for organic chemistry, we're going to spend an awful lot of time on application and comprehension. Okay? Can you apply the principles that you learn in this class? Can you apply the fact that we're only going to be largely working with carbon, hydrogen, nitrogen, and oxygen to make complex organic molecules? Okay? I want you to know that we learn by making mistakes and reflecting on those mistakes. Many of you are afraid to make mistakes because you spent all your time in high school. It's always been about the test. It's been about getting that grade and moving on. When you make a mistake, learn from it. That's very, very important. I can't stress that enough. I make mistakes all the time. Guess what? It's okay. As long as you learn from it, okay? If you don't learn from it, that's where it becomes a problem. We learn by experience, and I certainly believe that learning is equal to talent development. You all have talents. My job here is to help you develop those into the best talents that they can be, okay, within organic chemistry. I'm not going to help you play the clarinet or whatever else, okay? I don't know how to do that, all right? But I will help you develop your talents as a scientist and as an organic chemist, and so you can apply those to whatever your ultimate goals are in life. I'm very big into mindset. How many people know what I'm talking about when I talk about mindset? Good. There are two types of mindsets. There's the growth mindset and there's the fixed mindset. And a fixed mindset doesn't have to be how you are. It could be how you are right now, but you can actually change your mindset, okay? A person with a growth mindset realizes that a failure is an opportunity to grow. Guys, I'm in the business of failure. Most of my stuff that I do fails in the lab. And we learn from it and we move on. And we still get publications. We still get things funded. I still graduate graduate students. We learn from our failures and our mistakes. That's how we learn. Somebody with a fixed mindset goes, oh man, I failed. I must not be very good at that. Move on. You can be excellent organic chemists, each and every one of you. I have absolutely no doubt. Okay, but it's all about your mindset. Okay, I want you to have a growth mindset. If you feel like you're in the fixed mindset, try to think of ways in which you can adapt to a growth mindset. Do not look at a paper that I hand back to you and you go, gee, that's a 75, I wanted an A. Don't view that as a C. View that as an opportunity to learn and grow. And I know what you're all thinking right now, but that counts against my points, right? Okay, well, we'll talk about that. Class format. We're going to have lecture and class discussions. I encourage class discussions. It's the thing I love about teaching the honors section. We're small. If you don't understand something, throw your hand up and let's talk about it for a while, okay? Let's have some discussions about things. I'm on a lecture using PowerPoint like I am right now. The slides will be placed in Blackboard. They're there already, right? Screencasts will be posted to the YouTube channel, okay? USM OrgChem, you can find it on YouTube. I've got all my presentations from last year, and I'll put all the presentations from this year. Okay, I'll screencast them, and they'll usually be up the evening after the lecture, okay? It may be the next morning. We will have some concepts tests in class. They are not graded. It's for me to get a quick response to see whether or not you've got a topic, whether or not I need to move on or spend a little bit more time, okay? We will have inverted lectures. We will have online homework, and I will use Pencasts and YouTube and other things like that, okay? Class behavior, I don't need to mention this too much to you, right? I don't have a policy on you have to be here at exactly 9:00, but if you're here a little late, just come in quietly, don't make a scene, and sit down. If you're late too often, we will have a conversation, though, okay? But sometimes you're running a little late. Just come in and take the first available seat. All your electronic devices must be off or in silent mode. Please never answer a call during class or surf the net. You're disrupting your neighbors, and you're taking away from them their opportunity to learn, okay? It's not a real big problem for the honors class. It's usually when I teach the larger section that this is an issue. If you know that you're waiting on an important call for something, maybe there's something going on in your family or whatever, put it on silent. If it rings, get up and just walk out. It's fine if something's that important. But just don't interrupt the class too bad, okay? We'll move on. Course grading, the important things, right? So the inverted lectures are going to be 150 points total in the class. About 17% of the class is devoted to that. We'll have 3 regular exams, somewhere around 20 to 25 questions for a total of 300 points. It's about a third of the class. We'll have online homework, which will be about 22% of the class. We'll have a video project, which will be about 6% of the class, which is kind of a fun thing to do. And we'll have a final exam that is cumulative worth 200 points at 22% of the class for a total of 900 points in the class. So you can always figure out what your grade is. However, I'm going to read this to you. I believe that the primary goal of education is to grow and learn. I'm a believer in the growth mindset concept and that we should learn from our mistakes. I believe that students should be allowed to learn and improve throughout the semester. I promote this philosophy by allowing the final exam to replace your overall course grade if the final exam grade is higher than your cumulative course grade. Okay? However, to be eligible for this, you have to have completed all assignments, exams, and projects during the semester. In other words, you've given me your best all semester long, and you made some mistakes, and you're at a B going into the final, and you work really hard and you get an A on the final. I'm going to give you an A. Okay? It's cumulative. You've proven to me that you can do it. Okay? Now, you don't turn in assignments on time, you're going to get the cumulative, whatever it adds up to be. If it adds up to an 89, it's a B. Okay? At any point, you can get an A in this class if you do all the work. Okay? So at any point, it's always possible to get an A. The reason I do this is because at one point I realized that about 3/4 of the way through the semester, students who were progressing but had made some serious mistakes early on, they gave up. And I asked, why are you giving up? And they're like, well, it's mathematically impossible for me to do any better. Huh, okay. I'm going to take that away. It is mathematically possible for you to get an A, including the day of the final, if you do everything in the class, okay? Does that sound fair? Okay, good. All the exams will be offset such that the highest class score is equal to 100%, but I will not curve more than 10%, okay? So exam 1 comes around, the highest score is a 95, everybody gets 5 points. Exam 1 comes around, the highest score is an 85, everybody just gets 10 points, okay? So you can't all just get together and say, let's all do really bad, and he'll just curve us up to an A, all right? But every now and then I might have put a question on there that, not everybody got, and so maybe that wasn't fair. I'll curve it a little bit, okay? We'll do that. There are no makeup exams in this class, meaning I don't schedule any makeup. If you're going to be gone for a university-related function, I will certainly work with you. That is not what I consider a makeup. What I mean by makeup is, Dr. Masterson, I'm sorry, I overslept. Not a makeup, okay? So you got to be here and take the exams and do all the work. Okay. The grading scale in this class, I have been thinking about this for quite some time now. And think about it when you were in high school or in some other class. What defined an A? 90 to 100, right? What defined a B? 80 to 89. C? 70 to, roughly 80. And where did an F start? Okay. We devoted the vast majority of the scale to failure. That's not realistic, right? If I got 65% of all the grants I ever submitted funded, they'd think I was a genius. If I got 65% of all my papers published the first time I submitted it, they'd think I'm a genius. But for some reason, we think if you can't get better than 65%, you're a failure. I don't believe that, okay? So my philosophy is that an A should be something that you really have to work for, and an F is something, you really didn't work for it, So for me, to kind of spread the scale out a little bit and take a little bit more advantage, I use the following scale. 90 to 100 is an A. I take a B down to 77. I take a C down to 67. I'll take a D all the way down to 55. If you can do better than a coin toss, you'll pass the class, right? And an F is below 55%. So I believe in expanding that scale to really be a little more representative of what reality really is. That 10% slicing stuff was completely arbitrary. No thought whatsoever put into it, okay? And I think it's ridiculous. So we've expanded the scale a little bit. Now there are some student learning outcomes that you all need to be aware of in terms of this class, okay? These are things that myself and the other organic instructors got together and said, these are the things that you really need to know from 255 to go into 256, okay? And there's really only 6 things that we think you absolutely need to know in general. You'll be able to readily identify functional groups in a complex organic structure. That is, I'll give you a structure, and you'll be able to tell me what the functional groups are within that structure. You'll learn how to do that. Students will be able to utilize nomenclature and name organic structures and to derive a structure from a name. So when I tell you 2-methylpentane, you'll be able to draw it. Okay? You'll learn how to do that very, very well. Students will be able to use the fundamental spectroscopic techniques of infrared and nuclear magnetic resonance to elucidate structures. We'll learn how to do that in this class. Students will be able to illustrate fundamental reaction mechanisms through the use of arrow pushing formalisms and Lewis acid, Lewis-based theory. And students will be able to interpret diagrams and understand the thermodynamic and kinetic aspects of fundamental reactions. And you'll be able to do functional group transformation starting from hydrocarbons. Very important things. This is how your body works, actually, is functional group transformation. If you're out partying and you drink a little too much, it's a functional group transformation. Alcohol gets converted to acetaldehyde. That's a functional group transformation. We're going to learn how to do that on paper, okay? Now, I want you to look at your syllabus at some point, not right now, but at some point, and look at the description of how the student learning outcomes are related to the course grades. A student who will get an A in this class will be able to utilize all 6 of those student learning outcomes at an advanced level. Okay? And then it describes how it goes on from there. So that'll give you kind of an idea of what we're expecting you to be able to do when you leave this class. Okay? There is a class schedule in the syllabus today, right? Introduction, syllabus, and general chemistry review. Science study tips due for extra credit. Notice on Friday, we're going to be covering these sections. Okay? On Monday, we'll have our first inverted lecture, right? 31st, we'll actually have a catch-up and problems in class from Chapter 1. We'll be doing some things in class together. This is subject to change depending on how the class goes. Okay? I mean, you might stop me somewhere and say, yeah, I really don't understand that. And we spend a little more time, and that gets me just a little bit behind. But there'll be places where we may catch up. Okay? But there are some dates, barring natural disaster, that will not change. And that is the exam dates. So you know right now when all of your exams are. If you know you're going to be gone for something, you need to let me know so we can work about getting you the exam when you need it. Okay? If you're going to be gone for something, maybe you're taking the psychology honors class and they're doing the field trip, right? Or something like that. You know, when we'll work with you on it. Okay? Now, what happens if we only get to Chapter 3.8 before the exam? Well, we're not going to cover the rest of it on the exam. I can alter that, but the exam date stays the same. So you know right now what your exam days are. Okay? Any questions about that? Okay. We will do homework by sapling. I've already got some sapling homework up for you. Go in and look at it. How many of you have signed up for my Remind app? If you have not signed up for Remind, get signed up for Remind, because I go through Remind and pre-schedule reminders that will be sent to you about something's coming up. Okay, and it's a great tool to use. You don't have to have it sent to your phone if you don't want to. It can go straight to your email. But please sign up for the Remind app. You all know about the Blackboard shell, because most of you have gotten some materials already. Make sure you stay in Blackboard and look to see if anything changes. I want to talk a little bit about some research opportunities. So if you're interested in doing research in organic chemistry, we should probably talk at some point. I'm not taking too many research students these days, but I can point you to people who are doing some interesting work. And if you're a chemistry student or biochemistry student, you're required to do research in order to graduate. And I definitely recommend you don't put this off till the very last semester. What are some of the benefits of research? You can get your name on a publication, which looks really good on an app to med school. Okay? I have several undergraduate students that have their names on publications with me. You can receive course credit. We have courses that you can receive research credit, and it's variable from 1 hour to 3 hours. Letter of recommendation, this is the big one, I think. If you all come to me and ask me to write a letter of recommendation and you just were in my class, I can write you a pretty good letter of recommendation, but imagine how much better it can be if I actually worked with you on an independent project. I can start talking about your work ethic, your problem-solving skills beyond just the academic, right? I can talk about how you interacted with people in a laboratory setting, how you solve problems that I didn't know the answer to, right? That's what a research project is. We're working on it together, and I don't know the answer, right? Everything that we're going to be talking about in here, more or less, I know the answer to. At least I should, right? Okay. So, lots of good reasons to do that. Some of my current research projects are on small peptides. This is a glutathione analog that we've made that has some potential to be an anti-malarial drug. And so we've been studying that recently because it turns out that this thing is called glutathione, and it gets reduced in the cell to this free thiol, which is a reducing agent and keeps your oxidative stress down. And it turns out that our molecule actually inhibits that pathway, and it can increase the oxidative stress in the parasite that causes malaria and kill it, potentially. We're looking into those types of things right now. Also, we've been developing molecules that look something like this. Does anybody know what any of the functional groups are in there yet? You know some? What do you see?
Alcohol.
Okay. What else do you see?
Aldehyde.
This one isn't an aldehyde. This is a carboxylic acid. Yeah. This is an ester. This is an amine.
For R's, like,
Yeah, that could be methyl groups or other groups, yeah. So you're going to learn about this semester. You're going to be able to look at a molecule like that and go, these are what the functional groups are. You'll be able to do that by the end of this class. The language part of what we're talking about will become second nature to you by the time Christmas rolls around. Okay? And the scary thing is that some of you will wake up one morning and you'll have had a dream about some organic molecule. And it happens to everybody. It's really like learning a foreign language. How many people have had a foreign language? Yeah? When I was taking foreign language, I was taking Spanish, and I woke up one night and I was like, crap, that was in Spanish. Right? It was wild, right? And you will have, not everybody will, but some of you will have that experience, and it's kind of freaky. So let's talk a little bit about organic chemistry. Chemistry, in and of itself, is the study of matter and the changes that matter undergoes, right? And there are two main branches. There is organic chemistry, which is all about this class, right? It was a term that was coined by Berzelius in around 1807, so over 200 years ago, and it meant matter derived from living things. And today it's really the study of carbon-containing compounds, carbon, hydrogen, nitrogen, and oxygen. And technically, to be an organic compound, you have to have at least one carbon-hydrogen bond. One hydrogen bound to a carbon, okay? Technically, to be considered an organic molecule. And then there's the stuff that you learned about mostly in Gen Chem, inorganic chemistry, right? The rest of the periodic table. You know what? How I view the periodic table. Now, Dr. Wallace and I will disagree a lot on this, okay? But I view most of the periodic table as placeholders for carbon, nitrogen, and oxygen, okay? The rest of it, it is important. I shouldn't say it's not important, but it's boring as heck, okay? So it's the vast majority of the periodic table. It's rocks. That's a rock, right? I'm not a geologist, okay? Matter derived from living things. That's cool, right? Something's live. Why are we alive? Well, we're alive because organic chemistry. We're alive because carbon can have 4 bonds, okay? Not 5, but 4. If it could have 5 bonds, it would be silicon, and we're not silicon-based, and there's a reason for that, okay? Now, in early organic chemistry, there was this belief called vitalism, that organic compounds could only be derived by living things due to some vital force, okay? Then along came Frederick Wohler around 1828, and he observed that an inorganic compound could be converted into an organic compound. He saw that ammonium cyanate, which is inorganic, when heated in water became urea, which is an organic compound. It comes from a living thing. He disproved the theory of vitalism, okay? In fact, organic molecules can come from non-living things, okay? And so that's why today's definition of organic chemistry is definitely different than what it used to be, but we still use the term organic, okay? Ammonium cyanate and urea are isomers of one another. You all are familiar with the term isomer? Notice that the number and type of atom in each molecule is identical, but how are they different? The way they're connected. So structure and function are a big deal in biochemistry, a big deal in biology. You're going to learn the basics of that in this class, and that's why this is so important for you, okay? Tell you what, let's end it there for today. On your card, turn it over. Okay? And write one of your biggest fears about being in this class.